Hi students, this is a continuation of the session 4. That is session 4 we saw the minus pi comma pi interval. So here we are going to see the minus L comma L. So the same even and odd function we are going to see. So here we have to find the Fourier series expansion of f of x is equal to sin ax in the interval minus L comma L. So here we have to first to check whether it is a even function or odd function. So sin we already know the sin is an odd function. So here you have to check replace x by minus x, you will get the minus sin ax. So therefore this function is an odd function. So f of x is an odd function. So here the a naught, a n value, both the values are equal to 0. So we need calculate only the b n value. Here the f of x will not contain cosine terms. Therefore the Fourier series for the odd function is f of x is equal to summation n is equal to 1 to infinity b n sin n by x by L. Next one. So we are going to calculate the b n value. So b n is equal to 1 by that is 2 by L integral 0 to L cos n by x by L minus a minus cos n by x by L plus a x into dx. So here after that is a integration of 0 to L f of x is what is given sin ax. Then already we know the sin is sin nx dx. So we have to use the sin a sin b formula. So sin a sin b formula is cos of a minus b minus cos of a plus b. So a is equal to n pi by L. Then a b is equal to a. So here I replace a is capital A is equal to cos n pi by L minus a into x minus cos of n pi by L plus a into x dx. So now we have to split the integral. So integration of cos is we'll get the sin n pi by L minus a into x by n pi by L minus a. The same way for this term also. So now we are going to apply the limit 0 to L. If you apply the upper limit, the first term we get the sin of n pi by L minus a into L. The same way here also sin of n pi by L plus a into L. So we know that this one we have to write this as, so if you multiply the L inside we can cancel the L, you will get the sin n pi. So sin n pi minus sin AL. So similarly we have this term also we can write as sin n pi plus sin AL. After this one, we can write the sin from the both the term. We can take out the sin AL outside. The remaining we can write 1 by n pi minus AL plus 1 by n pi plus AL. So here take the LCM as n pi minus AL and n pi plus AL. We get the terms 2 n pi into sin AL by n square pi square minus a square L square. So using these values one we get this value. Next we go to the next problem. So find the Fourier series expansion of the period f of x of period 2L defined by f of x is equal to L plus x. It lies in the interval minus L less than or equal to x less than or equal to 0. And L minus x it lies in the interval 0 less than or equal to x less than or equal to L. Deduce that summation n is equal to 1 to infinity. 1 by 2n minus 1 the whole square is equal to pi square by 8. This is the deduction part. So now we have to consider this given f of x as, here we have to consider pi 1 of x and pi 2 of x. That is here the both the function is given. So here if you replace pi 1 of x in minus pi 1 in pi 1 of x in minus x replace, you get the pi 2 of x means therefore the function is an even function. Suppose if you take out the negative outside, then you're getting the pi 1 of x means you get that is a odd function. So if you can't replace, if you can't get the given f of x, therefore that is a neither even nor odd. So here consider pi 1 of x is equal to L plus x, then consider pi 2 of x is equal to L minus x. So now in a pi 1 of x replace x is equal to minus x. So we get L minus x. So this L minus x is nothing but the pi 2 of x. So pi 1 of minus x equal to pi 2 of x means the function is an even function. So even function means here the bn value is equal to 0. So even function means you have to take the limits from 0 to L. So in a 0 to L what function is having? So L plus x. So we have to take, here we are going to find the a naught value and an value. So a naught is equal to 2 by L integral 0 to L f of x dx. So f of x you have to consider here as a L minus x. So it comes under the interval 0 to L. So in a 0 to L, under this interval, the function is L minus x having. So I have to substitute that function alone. So no need to substitute the L plus x. So 2 by L integral 0 to L, L minus x into dx. So here after integration, I apply the limits. You will get the value a naught is equal to L. So similarly, we are going to calculate the an. An is equal to 2 by L integral 0 to L f of x cos n pi x by L into dx. Here the f of x is equal to L minus x. So substitute the L minus x. Though here we are going to use a Bernoulli formula. So consider u is equal to L minus x and dv is equal to cos n pi x by L into dx. So u dash is equal to minus 1, u double dash is equal to 0. Then similarly v1 is equal to sin n pi x by L divided by n pi by L. Then v2 is equal to again minus cos n pi x by L divided by n square pi square by L square. So after substituting the Bernoulli formula, applying the limit, we will get the result like this. That is an is equal to the here apply L minus x, here minus 1 we got. Then integration of cos is sine, integration of sine is minus cos. Then apply the limit. If you apply the upper limit, the first term becomes 0 because L minus L is also 0 and another term sin n pi value is also 0. First term won't come. So go for the second term. If you apply x is equal to L, L cancel. So you will get the cos n pi. So we know cos n pi value is equal to minus 1 the whole power n. Then plus L by n square by n L square by n square pi square. So here from the both the term L square by n square pi square is common. So take outside. So remaining term 1 minus of minus 1 the whole power n. So here in this case you have to check whether if you apply n is equal to odd value, what value we should get, we have to check. Then also we have to apply n is equal to even, we find the value of this an value. So if you apply n is equal to even, that is minus 1 the whole square, you will get the plus 1. So 1 minus 1, it become a 0. So this an is equal to 0 for n is even. Next one, if you substitute n is equal to odd value, that is minus 1 the whole cube, we get the minus 1. So minus into minus plus, you get the 2. So already 2 is having. So 4 L by n square pi square if n is odd. So now we have to write the Fourier series. F of x is equal to a naught by 2. A naught value already we find out L. So L by 2 plus summation n is equal to, this is only valid for n is odd. So take the n is equal to 135 up to infinity. 4L by n square pi square cos n pi x by L. So this is only our Fourier series. Next we are going for the deduction part. So here I have to check whether if we give any value for x, you should get the deduction part. We have to check which value we get the deduction part for given deduction part. So first to apply x is equal to 0. If you apply x is equal to 0, cos 0 value is 1. So cos 0 value 1, you will get the 1 by 1 square plus 1 by 2 square plus 1 by 3 square, 1 by 1 square. N is odd values only, no? So 1 by 1 square plus 1 by 3 square plus 1 by 5 square, etc. So this way you will get. So here you apply n is equal to 1, you get the 2 minus 1, 1 square. 2, 4 minus 1, 3 square. So we getting the deduction part. So we have to choose x is equal to 0. So x is equal to 0 is a continuity point. So we are considering only interval 0 to L. So in a, minus L to L. So minus L to L, x is equal to 0 is a continuity point. Minus L and plus L are both are the discontinuous point. So we have to write the f of x, instead of x substitute 0. So what is our f of x is given? L minus x is given. So there is substitute x is equal to 0, only get the L. So L is equal to this L by 2 plus 4L by n pi square. Then here we have to expand the summation. Then finally get the result. Summation n is equal to 1 to infinity 1 by 2n minus 1 the whole square equal to pi square by 8. That's all.